A warm welcome to all the viewers. Today's session of Tourism and Hospitality Research, we will be discussing about an important concept in research, that is normality of data, which is one of the preliminary steps in data analysis. So what is normality? In statistics, normality often refers to a normal distribution, a bell-shaped curve. While this distribution is common in many natural phenomena, it is not always a perfect fit. And the concept of normality is often used as an approximation or an assumption. What do we mean by this? I will explain you all of this in very simple and easy to understand wording. So stay tuned, keep watching. Normality of data refers to whether a dataset follows a Gaussian distribution or a bell curve. As you can see in this picture, the x-axis, the horizontal axis, is marks of students in a class, and the y-axis, which is the vertical axis, represents the number of students or the frequency. So why is this graph looking like a bell-shaped curve? So when I talk about normality phenomena, it says that the distribution of the marks of the students in a class are such that the mean, median and the mode lie at the center of the curve, and they all seem to be equal to each other. Isn't it surprising? That is why it is a hypothetical phenomena. When we talk about testing for normality, we are essentially testing if our observed data fits the hypothetical normal distribution or if it deviates from it. This implies that normality is a hypothesis that we can test, not a fixed reality. This is important in statistics because many statistical tests, called as parametric tests, can only be run after ascertaining the normality of data. If it deviates from normality, the results of test may be questionable and your research will go in vain. I hope it is becoming a little clearer to all of you. Those who are attending this concept for the first time or listening to this concept of normality for the first time, it might seem a little difficult for you to understand, but I bet I will make you understand this thing very simple way in just few slides. Stay tuned, keep watching. So how do we assess normality? In SPSS software, that is Statistical Package for Social Sciences, we usually test in for normality of data, and we get Shapiro-Wilk test or Kolmogorov-Smirnov test. Level greater than 0.05 to prove that the data follows a normal distribution. They are both used to assess whether a dataset follows a normal distribution. However, they differ in their power and suitability for different sample sizes, as the Shapiro-Wilk test is generally preferred when we have, that is, the representatives who have answered the questionnaire is less than 50, while the Kolmogorov-Smirnov test is used when we have larger samples. We can use to assess the normality of data is by looking at the normal probability plot, also known as QQ plot. This plot also we get through the SPSS. The values which are known as quantiles divide a probability distribution or sorted data into equal portions. Sorted data is generally divided into Q portions by a Q quantile. The quantiles that are most frequently used have unique names. For example, 4 quantiles, or also known as quartiles: Q1, Q2, Q3 and Q4. This means the data is divided into 4 sections by 3 points or 3 quartiles. By comparing the quantiles, determine if the data follows a theoretical distribution. This is merely a visual inspection and does not ensure a definitive response. So as you can see in this picture, there is a straight line and the points or the observations lie on that line. If any of the points lie very far away from this straight line, we say they seem to be potential outliers in our data. We need to identify the outliers and remove them before going further in for data analysis. We can also assess normality by looking at the box plot, which is a graphical technique for visualizing the data distribution that helps with. Box plot is a kind of graph that shows a set of numbers according to their quartiles. Distributions of numerical data values are displayed using box plots, particularly when comparing them across several groups. They are designed to give high-level information quickly, including details like the variance, symmetry, skew, and outliers of a set of data. Dots or circles which are visible outside the whiskers indicate outliers. So here, as you can see, there is a middle point which is known as median, and the interquartile range divides the data into Q1 and the upper quartile Q3. And there are whiskers. On the left side we have the minimum and on the right side we have the maximum. So any point of data or observation which lies outside these whiskers happens to be a potential outlier, and we must try to identify and remove it from our data before going in further for analysis. Now let us talk about what is skewness and what is kurtosis. We get the value of skewness and kurtosis when we test in for normality using SPSS. But how to assess? Skewness focuses on the asymmetry of the distribution. A skewed distribution can be left skewed and it could be right skewed, which is also known as positively skewed. So as you can see in the left side graph, the x-axis which represents the marks of students in a class, and the y-axis, the vertical one, which represents the number. So I've drawn this graph to make you understand the concept of negatively skewed data in a very easy language. So as you can see here, more of the students in the class secure marks in a test which is more than the mean marks of the class. Then the distribution is known as left skewed distribution. If more which are lesser than the mean marks of the class, then we call it a positively skewed or right skewed distribution. That is why you see here in the first graph, left skewed graph, the mean is smaller than median and median is smaller than mode. What is mean? Mean is the average. So total marks secured by the students in the class divided by number of students gives you the mean. Median is the middle point of the series of the marks which are displayed in ascending order. What is the middle point? If the marks of the students are displayed or written down in ascending order. That is known as median. What is mode? Mode is the marks which occur most frequently in that data series. So we see that in a left skewed distribution, the mode is the highest because most probably there will be a number which occurs more frequently, and that number would be on the higher side because most of the students in the class have secured marks. Kurtosis focuses on peakedness of data, leptokurtic values, and a higher probability of outliers. Kurtosis value given by SPS: sharp peak, heavy tails. Example, a class where most students score very close to 80 out of 100, with very few students scoring around 60 or 100. The distribution would have a sharp peak at 80. So you see here the black line which I have drawn, the black curve which I have drawn on the graph represents the leptokurtic or the leaping distribution. Mesokurtic is a distribution with a normal tail and resembles a normal distribution with rare extreme values. Here, the value of kurtosis is 3. Excess kurtosis is 0. That means perfect normal distribution or very close to it. The orange curve line which I have shown on the graph represents the mesokurtic distribution in this case. Third one is the platykurtic, where a distribution indicates fewer extreme values and less probability of outliers. In this case, kurtosis happens to be lesser than 3, excess kurtosis lesser than 3, flat peak, light tails. Example would be many students scoring 60 to 90, marks within the bracket of 60 to 90, with very few in the extreme values. This is known as platykurtic. The blue curved line represents the platykurtic distribution for you to understand it in a better manner. Next, what if our distribution is skewed or kurtotic? There are different guidelines on which we can assess whether our data can be executed for the analysis through parametric statistical techniques, or we need to go in for non-parametric measures. I will talk about parametric and non-parametric tests later in our upcoming video, wherein I will make you understand that what is the difference and what are the assumptions of parametric and non-parametric tests, what kind of data or what kind of measurements could be taken in for analysis through parametric, and what kind of scale measurements and character data could be taken in for non-parametric tests. But here it is important to know that ideally when we talk about skewness, minus 1.96 to plus 1.96, or roughly minus 2 to plus 2, is the range. If we get a number through SPSS analysis which says that the skewness is between minus 2 to plus 2, then we can say that our data is approximately normal and we can go in for parametric analysis. Similarly, if kurtosis is between minus 3 to plus 3, as we saw in the case of previous slide, kurtosis value lies between minus 3 to plus 3, then again we assume that our data follows a normal distribution and we can go in for a parametric test analysis. Then what is central limit theorem? Regardless of the distribution of the population, the central limit theorem or CLT asserts that as sample size increases, the distribution of sample means approaches a normal distribution, also known as a bell curve. What does it mean? It means that as you will increase the sample size, the curve of the distribution of the sample means will be more closer to recommending a higher sample size for survey-based studies so that the features of a population can be more precisely predicted. Some people recommend that sample size of 30 or more are frequently seen as adequate. Though we have different sample size calculation formulas like Yamins, Cracky and Morgan, Cochrane, which guides us through what should be the sample size of our study. What should be the adequate minimum sample? There are different softwares for calculating the sample size. Online softwares are also available, and a very well-known software known as G-Power is being used by researchers all over the world. So I will tell you how to use G-Power as well in the upcoming videos. The average of the sample means and standard deviations will match the population mean and standard deviation, which is a crucial component of CLT. Herein I have given a reference of Ganti 2007 central limit theorem, which tells some more useful resources which will be definitely a boon for you to know more about these concepts. Very nice recent paper from Ahmed et al. 2019, which talks about descriptive statistics and normality test for statistical data. And one more resource for you. I hope the session was quite useful and interesting, and you would be waiting in for some more knowledgeable content from the channel. Stay tuned, keep watching. Thanks a lot.